Okay, in this video, we'll look at the homework in section 9.3. There's only like two problems. It deals with simulations. Okay, in this problem, we have an estimate of the fish population was found by catching 200 fish and marking them and returning them to the pond. The next day, 400 fish were caught, of which 50 have been marked the previous day. And we want to estimate the fish population in the pond. Okay, so here's how we're going to attack this particular problem. We want to I'm going to let N be the fish population. Okay, now we're going to have to work backwards on this particular problem. That's one of the strategies for doing these type of word problems here. We find that the next day 400 fish were caught, of which 50 of them have been marked the previous day. So here, 50 that were marked out of 400 that were caught. So that's 50 over 400 multiplied by N. That's going to equal to the 200 fish that were caught on the very first day. So here we have an equation, 50 over 400 times N is equal to 200. Now I'm going to reduce 50 over 400 to, let's see, 1/8. So now I got 1/8 N is equal to 200. And then I'm going to go ahead and solve this equation for N. I'm multiplying by 1/8, but it'll be easier for me to multiply by the reciprocal of 1/8, which is 8. So here I'm going to multiply both sides by 8. So here I'll have N by itself because the 8's divide out. So here 200 times 8 will be 1600. So here we can estimate that there are 1600 fish in the pond as a total population. Okay. So here, this is how we particularly set up this particular problem here. So you have to pretty much let N be the fish population and then start working backwards here to come up with an equation that you can easily solve for N. Okay. All right, problem number 2. Another problem is similar to number 1 that I just did. And that is, to determine the number of deer in a game preserve, a forest ranger catches 164 deer, tags them, and releases them. Later, 100 deer are caught, and it is found that 45 of them are tagged. Estimate how many deer there are in the game preserve. Okay, so here we're going to do the same thing like we did in problem number 1. I'm going to let N be the deer population. Okay, now we're going to work backwards here. We see that 100 deer are caught, 45 of them are tagged. So it'll be 45 over 100 times the original deer population, which is N. That's going to be equal to the number of deer that were caught originally, 164. So we have an equation 45 over 100 times N is equal to 164. Now to solve for N, it would be easier to multiply both sides by the reciprocal of 45 over 100, which will be 100 over 45. Now, if you wanted to, you can multiply by 100 and then divide by 45. You'll still come up with the same answer. So here on the left side, I'm going to have N by itself because the 45s are gone and the 100s are gone. So now you got 164 times 100 divided by 45. And they ask in this problem to approximate, so that means we're going to round to the nearest integer, or in this case to the nearest whole number. So if you do 164 times 100 and divide by 45, you'll get 364.4, and it repeats. But we run around to the nearest whole number, so it will be approximately 364. So here there are approximately 364 deer in that entire population in the game reserve. Okay, so that's how you will do those particular type of problems that are related to simulation. Okay, and that should assist you with some of the homework in section 9.3.